And Mrs. Downer asked me to record because she can't be in 7th grade. You guys, there's an answer key to this page up on, like, in the, if you go in the notes folder, there's like a completed notes for 2.1 through 2.3. This is here if you want some extra practice, you don't have to do it. But the answer key's already up in Schoology. But we're going to jump to the 2.4, which is relationships among quantitative variables. So at one point, this was real data. I think it would change now because I don't know that I could even run miles this fast. I'm not in this kind of shape anymore. But these were legitimate mile paces and heart rates, average heart rates for different runs that I tracked on my watch. Okay? And so did we talk about explanatory and response variables yesterday at all? We talked about independent, dependent? Okay, so the explanatory variable, y'all, is the independent variable. And the response variable is the dependent variable. And sometimes we will have very, very clear and obvious explanatory and response variables. Sometimes we don't. Sometimes there isn't like this is definitely my explanatory response variable, okay? So we typically put the explanatory variable on an x-axis. We put the response variable on a y-axis. All right. So in this particular case, do we have a clear explanatory and response variable? What's my explanatory variable? Okay, that's the part I have control over, yeah? And then the response would be my heart rate. And without we'll talk about this a little bit more in a second. Okay, so from here, y'all, what kind of graph do you think we should make to explore what happened, like the relationship between these two variables? First of all, do you believe that there would be a relationship between, say, my pace and my heart rate? What do you think that relationship might be?
A negative relationship?
How many of you guys agree with negative?
Or one.
Would it go up or go down?
I was thinking that when one goes up, the other goes down, so I would say it's a negative, not a positive, or they both go at the same time.
Because Udo, I like it. No, I like that you called it negative. Most students assume this is going to be a positive relationship. I would prefer you say negative, for sure. What kind of graph should I draw? This is one of the ones I know you've learned. You would have done it in Algebra 1 and theoretically Algebra 2. We would draw something called a scatter plot. And like I said, we put the explanatory on the x-axis, so I'm going to go ahead and put pace here and heart rate here. And guys, remember, a lower pace equals higher effort. Is everybody with me? Like when running faster is harder than running slower? Yeah. Okay, and so could I ask you guys to, it doesn't have to be good, but let's kind of sketch this scatter plot. Do scatter plots need to start at 0? They do not, okay? So I might put a little break in this axis, but I'm going to have this start at, what's my lowest pace here, y'all? So maybe we start with 8 and go up to 12? Because it looks, does that make sense? We should put this at 10, this at 9. Can we plot some points here? Are you guys comfortable with just like kind of coming up with a scatter plot and then we'll go from there? Or I can teach you how to draw the points, but most students feel like I'm talking down to them if I teach them how to draw a scatter plot. I don't want to do that. Now, do you need to draw them perfectly? No. Am I going to make you draw one on a test? Probably not. Maybe on a homework, but not on a test. I'd give you the grid paper. Okay, that's not the big picture of this. What is the big picture? What story does this tell?
As pace increases, heart rate decreases.
Okay, as pace increases, heart rate decreases. And does that feel good? Does that feel like what it should be? Yeah. What else do you guys notice? Any big ideas that we see besides just that negative shape or negative direction of this? Does it appear to look almost linear? Does it look like it's a line would be our best bet? Okay, what else? Anything jump out at you from this graph?
Point just before 12 might be out.
This one?
Yeah.
This one looks like it could be like something weird's going on here. In fact, that particular day, something weird did in fact happen. Yeah, I was running with this guy. I call him Slowpoke Indykins. He's built like a greyhound, but he runs like a bulldog. You have to pull him because he's the worst. So that particular day, Indy's like, he'll run really fast and then he'll walk for like a half mile and then he'll run for like a tenth of a mile and then walk. And you know, he's a boy, so he has to pee on everything. You guys know dogs, right? Boy dogs are the worst. They pee on everything. Actually, so does our girl dog. So maybe. So first things first. Remember if I gave you a histogram or a dot plot, what did I need you to describe when you saw a histogram or a dot plot? Shape, center spread, maybe unusual points if they are there. Yeah? All right. Can we talk about shape, center, spread when we have two different variables? Like which center are we talking about? The mean or the pace or the heart rate? And in fact, we don't necessarily care about the individual variables. We're looking at the relationship between the two. Okay, so there will be three things I would like you to describe about scatter plots. They are the strength, the form, and the direction. Okay. So we're looking at a relationship. So let's talk about strength. Does this look like a strong relationship? Like, would you feel comfortable if I said, guys, I'm going to go run today. I'm going to try to run a 10-minute mile. What should my heart rate be? Would you feel comfortable making that guess for a 10-minute mile? Why are you comfortable with that? All right, so what if I said an 11:25 mile? Right here. Could you still make a guess? Because it's somewhat linear. Not only that, are you guys with me that it's not just linear, but they're actually really close to the points would be kind of close to that linear trend. Right? They're not all over the place. They're pretty condensed. Okay? So we'll talk about strength in a lot more detail in a second, but in general, I would say there is a strong Yeah, they're in that one. Okay. Okay, talk to me about form. When we talk about form, you guys, we're just trying to decide, is it linear or is it curved? And when we look at this, even though it's not like they're not in a perfectly straight line, right? They're not going to be, because this is statistics and we have variability. Does the overall form look like a line is the best guess as to what these points are following? Okay? So we say there's a strong, linear direction. It's going down, yeah? As one goes up, the other goes down. So negative relationship between pace and heart rate. Did I talk about those three things in context? That's it. That's all you would have to say if I asked you to describe what you see in the scatter plot. So far, how are we feeling?
What would be a situation where it wasn't strong, but it was linear?
I would not call that a strong relationship. I still say this is the best guess at that equation, but they're a lot further from the linear trend. Speaking of strength, let's talk about something called correlation. Now, this might have been something that through all like the different weird COVID shutdowns, and we all took Algebra 1 and Algebra 2 at different times. Okay, have you guys ever seen the variable r before when talking about this stuff? Yes, no? Okay, great. All right, you guys, r is what we call the correlation coefficient. Okay. So, yesterday we were talking about two-way tables and we were looking at relationships between two variables. We would call that between two categorical variables, we would call it an association. Two quantitative variables, we call it correlation. When you interchange those, I'm not going to care at all. Okay? But technically it's correlation when it's quantitative and association when it's categorical. Okay, so R is a special number. I'm going to show you how it's calculated, kinda, on the next page. Okay, some things you should know. R is always in between -1 and +1. And if R is equal to 1, the scatter plot might look like this. Perfect straight line. If R equals -1, the scatter plot might look like this. Perfectly straight line. Everybody good? If R equals 0, the scatter plot might look like this. No line is good. There's no relationship between these points. What's happening with X doesn't seem to influence Y at all. And there's all sorts of varying stages of R. Like I could do R equals 0.94. And that one is going to look positive, but not very spread out. Whereas R equals 0.3 might look still positive, but going up. And so going up, but a lot more spread out than, say, R equals 0.94. Everybody okay? There's one more thing. The human eyeball is really bad at guessing correlation. We measure it. There's a statistical calculation that's going to be done. Because could I mess with the scales of a graph to make it seem less spread out or more spread out than it actually is? And all that would take is messing with the scales. Cool? All right. So what is R in terms of calculations? Well, you know. Okay, so here's what we did. This is a scatter plot of that exact same data set, obviously a little bit more precise because a computer program did it instead of... And what I did here is on this graph that I created, which wouldn't be that hard to do, but don't worry about having to do this, okay, is I kind of, this blue bar here, that's the mean of all the paces. Does that make sense? And this yellow horizontal line, that's the mean of all the heart rates. And if we were to, if we wanted to, could we almost like compute z-scores along the x-axis and z-scores along the y-axis? Do you guys get what I'm saying there? And if I did that, this would have a z-score of 0, as would this. And then we would count like 1, 2, 3, 1, 2, 3-ish. Are we comfortable with that idea? Okay, so when we look at, say, this point right here, what can we say, how many z-scores could we associate with it? 2. What's one z-score? If I had to describe where this point is, where would you say? I'm sorry? Okay, so it's zx, so it's essentially way to the right and way down. Are we cool with that idea? Okay, so it has two z-scores. One compared to the pace and one compared to the other thingy, the heart rate. Yeah? All right. And what can we say about a z-score for pace? It's positive and large. Not only is this to the right of the mean, but it's like way right of the mean. Okay, so here's what I'm going to do to kind of, next to each of these points, I'm just going to talk about the z-score of its pace for now. Is everybody okay? All right, so I'm going to say the z-score of that point is really, really positive. This is like, not only is it positive, the magnitude of it is very positive. We okay with this idea? And I move this way, and for this point, its z-score is also positive, but not as positive. Are we comfortable with that idea? And you guys kind of get what I'm saying? So everything to the right is going to be positive, but as I get closer to the line, it's getting a little bit smaller. And then over here, this is a negative zx, negative, a little bit more negative, a little bit more negative, really negative over here. Are we comfortable with this idea? And those are our z-x's. Okay. Now, let's talk about the y-coordinate z's. Okay? When I look at this point, in terms of y, how would you describe this? Negative z-score. Negative by a lot or negative by a little? A lot. So I'm doing, and this one also negative, but not by as much, right? And that's going to be a really short negative because it's close to the line. So I'm attempting here to make the value of the plus and the minus signs influence how big I make that plus or minus sign. Okay. You guys. Next. Imagine for each and every one of these points, we multiplied these two values. Everybody with me? Okay, so this, what is the overall value of a positive times a negative? Negative. And those are both really big negatives. Is everybody with me? Like, we almost might call that one like -9 or something. It's really, really influential. Okay? And then this one also negative. And in fact, everything in this third quadrant is negative if I multiply those things. What about this one? What can we say about these ones, guys? They'll be positive. Super positive or like tiny positive? Tiny, because both z-scores are pretty darn close to 0, yeah? You guys get what I'm saying there? Okay, so we have a couple positives up here, and we have like one positive in this quadrant, and then all of these are negative up in this corner. Is that everybody good on how that kind of would work itself out? So we can almost think of the means as like x and y axes. They're not the x and y axes, but we can kind of start to think of them that way. Okay, so here's what r is. R is equal to the average of these products. So as we start looking at just the purples, right? I'm averaging a lot of negative numbers with a very small amount of positive numbers. What's the overall result going to be? Negative. So this has a negative correlation. Does that make sense? So when most of the points are in these two, it's a negative, and when most of the points are in these two, it would be a positive correlation. But start thinking through what a scatter plot would look like that way. It would have a positive slope, yeah? Okay? And for something that has a very weak correlation, if it was like a big jumble of points, you'd have a lot more points here. You'd have these, but you'd also probably have more. Does that make sense? Okay? And so all of a sudden, you're still going to have more in the top in one direction, but there's a lot more in those other quadrants. Does that kind of make sense? Okay. So if I wanted to sketch a graph of that, and we have bad correlations, I'll make it positive, but spread out. And here's about my x and y mean. Yeah, I have more points in this area, positive, and less points in these negative areas. But overall, when I average them, they're going to cancel out and get closer and closer to zero as we get weaker and weaker relationship. Now, you guys will not have to do any of these calculations, okay? Your calculator does them, or I will give them to you. What I need you to get is R measures how strong a relationship is. R equals strength. And the reason it works is those like differences in quadrants. But it's not that big a deal, okay? And if it's positive relationships happen when R is greater than 0, negative relationships happen when R is less than 0. Okay, so I actually calculated R for that graph up above, or for our things, and we got R equals negative 0.93. That is what the R for that relationship is. Would you say that negative 0.93 is close to negative 1 or far away from negative 1? Close. So would this be very strong, very weak? What kind of relationship is this? I would call this very strong. Negative and strong. So when we talk about what does R tell us, it talks strength and direction. Okay, you guys, what would happen if I took this point completely out? So that's no longer our scatter plot. It's gone. Would that increase, decrease, or keep the same correlation? And you guys with me that one was the one that had the biggest negative value? So when I take the average, isn't that average going to get smaller? Did you guys get what I'm saying there? Okay. So if I remove that point, the correlation would decrease. Can I just remove that point? Well, that gets a little bit weird. Okay. Now, what if instead I pulled out the 9.62? That would be this point. Did that point affect the correlation a lot one way or the other? No. So if I remove that one, the correlation would stay the same. So we call this point, and really any point that's super out wide, this is a high leverage point. It affects the correlation. The ends affect the correlation way more than the middle does. Are we feeling okay? All right. Just a little bit more and then we'll be done. Okay. Definitely not going the whole time today. All right. You guys, r squared so r is equal to our correlation coefficient. R squared is called the coefficient of determination. So there's a difference between r and r squared. Okay? All right. So what would the value for r squared in this case be? Like, what would we need to do? If r was equal to negative 0.93. Yeah, you're just going to do negative 0.93 squared. I have no idea what the answer is. I'm not very good with numbers. Are you cool if I call that 86.5%? Typically, with r squared, we talk about r squared in a percentage. Now, r squared has a very, very, very specific interpretation. Okay? There's going to be lots of very specific interpretations for this particular unit. Okay? So, to interpret r squared, we always do, it tells you what percent of the variability in y is explained by the linear relationship with x. I have a great demo to kind of explain this later. So if I want to interpret this in this particular case, we might say 86.5% of the variability in heart rate can be explained by the relationship with pace. Okay. You guys, I want you to envision years and years and years, like pick a coastal city, and then for years, many different years, a scatter plot that on the x-axis has ice cream sales on a coastal city, okay? Y-axis has shark attacks. Guess what? That scatter plot would have a positive correlation. There's a strong correlation between ice cream sales of an area and the number of shark attacks in that area. Everybody with me? And this is actually true. Like, I'm not making this up. Do any of you believe that eating ice cream causes you to get attacked by a shark? Did I even say that? That felt very icky tense-wise. That's not right. Causes you to get attacked by. Was that right? Grammar-wise? It didn't feel good. Do you guys think that eating ice cream causes you to get eaten by a shark? Anyone? Anyone? No one? No one believes that? So what's going on there?
They both increase in summer.
They both increase in the summertime, right? So just because two things increase together doesn't mean one causes the other one to increase. Are we comfortable with this idea? And in fact, for Unit 2, we will not conclude any cause and effect, only correlation. Okay? All right. So likewise, does my pace cause my heart rate to go up? Maybe, maybe not. Are there other factors that also influence my heart rate while I'm running? What are some things that might affect it? My typical, is it a rest day? Is it did I rest the day before? For today, that answer is yes. I didn't run yesterday, guys. Okay. What else? Night versus day. Terrain. You guys, have any of you ever walked, run, or biked from Giant Eagle to here? It's not just uphill. It's a mean uphill. It's so subtle you don't feel like you're going uphill. You just feel like crap the entire time you're doing it, right? Okay? When I used to live in Grandview, I was training for a marathon and I was like, why is it always so hard the last mile? Well, I ended up figuring that out, by the way, guys. Those are the uphill, okay? So certainly we've got terrain. We've got, I'm going to go with caffeine intake. I don't know about you guys, but I live on it. And if I'm running in the morning, I've had a lot more caffeine than in the afternoon because I slow myself down so I can sleep. Weather, right? If I'm running into a headwind, that makes a big difference. You guys with me? So all of these other things can also explain the changes in my heart rate. But my pace is probably a pretty decent amount of the predictor of how much my heart rate is going to go up or down at any given time. How are we feeling? All right, I'm going to shut up then.